Assalamualaikum, hi guys. Okay, so today I would like to share on the past year question on mathematical induction. Okay, which is on chapter 7, proof technique. Okay, past year question on mathematical induction. Okay, hopefully this is helpful. Okay, so this is one of the past year question. Okay, regarding to the subtopic mathematical induction. Okay, given a series of numbers 1, 2, 3, 4, 5 until n, for all. Okay, this symbol is for all and in positive integer. So means that semuanya adalah positive integer. Okay, so by using mathematical induction, show that for all n in positive integer, 1 square plus 2 square plus 3 square plus until n square is equal to n, okay, times n plus 1 times 2n plus 1 over 6. So the first question is 8 mark. You can see here. So you boleh estimate lah. Okay, macam mana nak score this final exam. Okay, and the second question is determine the sums of 17 square plus 18 square plus 19 square plus until 2017 square plus 2018 square plus 2019 square. This one 3 marks. Okay, so we will see one by one. Alright, so let's see the first one. Okay, for this question. Okay, so by using mathematical induction, show that, okay, for all n, okay, is in positive integer. So ingat mathematical induction, we have 4 steps. Okay, we have only 4 steps that you have to memorize, you have to understand. The most important thing is that you have to understand. Bagilah apa soalan pun, kalau you faham the steps, okay, insyaAllah you will do. Okay, so the first one, what is the first step? Okay, what is the first step? Okay, so kita let dulu, let Pn, okay, 1 square plus 2 square plus 3 square plus until n square equal to n plus 1 to n plus 1 over 6. Okay, so number 1, so this one bukan number 1 lagi lah. Okay, so this one is proof that the first step is a proof that the statement is true for n equal to n naught, which is equal to what? Okay, look at the initial value on the series. Okay, you ada 1 square, so 1 square sama dengan 1 lah, 1 square, so which is 1 lah. Okay, prove that the statement is true for n is equal to n naught equal to 1. So you can consider on both sides. This side kita panggil left hand side and the other side for sure will be your right hand side. So let's consider left hand side first. So left hand side you ada apa? You nak substitute n equal to 1. So dekat sini je lah you boleh substitute. So n square, so equal to 1 square, so equal to 1. So how about your right hand side? Your right hand side you have n plus 1 2n plus 1 over 6. And bear in your mind your n now is 1. Okay, substitute 1 into the equation. Oh, sorry. Okay, and here is 1 now. One plus 1, 2 times 1 plus 1 over 6. Okay, so 1 times 1, 2. 2 times 1, 2 plus 1, 3. 1 times 2 times 3. 1 times 2 times 3 over 6. So which is 6 over 6 lah, which is 1. So you can see left hand side is equal to right hand side. So since again left hand side equal to right hand side equal to 1, then the statement is true. Okay, so let's go to the second okay, step. Second step ni apa? Second step ni senang saja. We assume. We just make an assumption. Assume that okay, the statement okay is true for n is equal to k. Right? So assume that you tulis ni ada markah ya. So assume that p k is equal to 1 square plus 2 square plus 3 square until plus n square. So until n sekarang dah jadi k lah. Okay, until k square okay, so equal to k times k plus 1 times 2k plus 1 over 6. Okay, so that is number 2. Okay, number 3, we prove that the statement is true for n is equal to k plus 1. Okay, so prove that. So we want to prove that the statement is true for n is equal to 1 based on our assumption on the second step. Okay, so macam mana? Rewrite 1 square plus 2 square plus 3 square plus until n square. Until okay, n sekarang n square kan? N sekarang is n equal to k plus 1. So dia akan jadi k plus 1 square. So equal to n which is k plus 1 plus dengan n plus 1. So n adalah k plus 1 again, plus 1. And you have 2n, which is k plus 1 plus 1 over 6. Yeah. So rearrange. Okay, you have k plus 1 times what? K plus 1 akan jadi k plus 2. Okay, and then here you have a 2k plus, okay, 2k plus, sekejap, betul tak soalan ni? Then 2n plus 1. So 2k plus 2 plus 1. So akan jadi 2k plus 3. So over 6. Sorry lah. Okay. Okay, nanti ada yang confused macam mana dapat this one. So our n now is k plus 1. So remember this one is n. This one is n plus 1. This one is 2n plus 1, isn't it? So you expand and rearrange, you got this one. So inilah yang kita akan guna. Okay, yang ini yang kita akan guna. So macam mana nak prove? Okay, kita akan consider left hand side sebab left hand side lebih complicated. Okay, so left hand side we have, okay, 1 square plus 2 square plus 3 square plus until plus k plus 1 square. Okay. Alright. Ini sebelah kiri ya. So sama juga dengan, betul tak saya kata sebelum k plus 1 dia adalah k. Betul tak? Sebelum k plus 1 adalah k. Contoh 1 square plus 2 square plus 3 square plus, sebelum k plus 1 dia adalah k. Ini jadi square. Betul tak? Katakan k adalah 9. So after k, okay, contoh 9 square, so kat sini akan jadi k plus 1 lah, square. Kalau k adalah 9, ni k. Okay, k adalah 9, so k plus 1, 9 plus 1, 10, 10 square. So betul tak? Betul tak? Kisahlah k 5 pun, okay, so you ada 5 square tambah dengan k plus 1 kan. So 6 square. Okay, faham ya? So that's why kita ada k square dahulu, baru ada k plus 1. K square ni k lah, tapi sebab everything okay, squared, right? So k pun kena square, k plus 1 pun kena square. So, and do you notice that our second assumption, we have 1 square plus 2 square plus 3 square until plus k square, okay, is equal to this one. Betul tak? Okay, betul tak? Okay, so betul tak saya kata 1 square plus 2 square plus 3 square until plus k square yang ni sama dengan step kat nombor 2. Sama tak? Sama kan? This one equal to what? Equal to this one. So you boleh replace Okay, so macam mana nak replace? Okay, so dia akan jadi like this lah. So this one equal to here. Ni equal to apa? This one. K plus 1, 2K plus 1 over 6 and then plus this one. Ni lain K plus 1 square. Okay, K plus 1 square. Okay, siapa nak buat next? Apa nak buat? Next adalah kita samakan apa nak buat? Kita kena buat apa? Factorize K plus 1. Betul tak? Oh, sorry. Okay, so what's next? Okay, apa yang kita nampak kat sini adalah kalau awak perasan dekat sini kita ada K plus 1, dekat sini also kita ada K plus 1. So apa boleh buat? Sini ada K plus 1, here also we have K plus 1. Apa boleh kita buat? Okay, kita factorize. Factorize apa? Factorize K plus 1 lah. Okay, so you factorize K plus 1 to the front, bring it forward, K plus 1. Okay, so yang tinggal adalah K dengan 2K plus 1. And then this one adalah dah ada K plus 1, so dia akan jadi K plus 1 sajalah dekat sini. Tapi bear your mind, this one is over 6. So ini pun mesti samakan dia punya denominator, penyebut. So kena darab 6 lah. So barulah everything is over 6. Okay, got it? Okay, so apa nak buat? Okay, apa nak buat? Kat sini. Okay, you factorize. Okay. So, saya sambung dekat sebelah lah. Okay. Okay, so saya sambung daripada previous slide. Okay, this one daripada previous slide. Okay, here. Kan, so saya sambung di sini. So you can clearly see. Okay, so you dah factorize tadi. So apa nak buat? What is the next step? Kita expand this one lah and then simplify. So we factorize K plus 1. So here kita pakai round bracket. Now for this one kita pakai square bracket lah. So expand, you got 2K square and then you got K plus 6K plus 6. Okay, don't forget to over 6. Okay, so next, apa nak buat? Okay, again K plus 1. Here you can factorize. Okay, 2K square plus 7K plus 6. So you akan dapat apa? You akan dapat 2K plus 3 and also k plus 2. Betul tak? Kalau you expand 2k dengan k, you got 2k square. 2k times 2, 4k plus 3k, 7k. 3 times 2, you got 6. So again, don't forget to over 6. Okay, so rearrange lah. You got k plus 1, k plus 2, and then you got 2k plus 3. Okay, rearrange and again, don't forget to over 6. And then this one, do you notice actually equal to what? Equal to right hand side of the equation. So equal to right hand side. So, okay, so therefore, okay, step number 4, okay, therefore the statement 1 square plus 2 square plus 3 square plus until n square is equal to n plus 1 to n plus 1 over 6 is true for each, okay, integer n greater than or equal to n naught. Okay, so untuk conclusion, you can memorize lah, awak boleh hafal. Cuma, okay, this one bergantung kepada question. Depends on your question. Okay, kalau question you dapat lain, so kat sini berubah, otherwise remain. Okay, otherwise remain. Okay, that is question number 1.